And he's like, yo, no. All right, guys, how we doing? Glad to be back. Not either. Couldn't see your faces, huh? All right, guys, focus. I'm on page 55. We're going to jump back into some limits. We got a test on Wednesday. We're going to play our limits game, I think, tomorrow. Wednesday. We're going to play our limits game tomorrow. Isn't that right? Yes. Remember, guys, the limits game is a team game. So if you come in unprepared, you will be an anchor. Not an anchor that holds your ship firm, but an anchor that pulls you down to the bottom. I don't know, maybe an anchor's not a giant weight, dead weight. Don't be the dead weight on your team. So guys, prepare like your test is tomorrow, and then I'll hopefully expose any last little bit of confusion you have through this game, and you'll be in great shape for Wednesday. All right, so this is just me. I'm just pulling out some old AP questions that show up. Just because they're on the AP test doesn't mean they're like, oh my gosh, super hard. We cover limits much harder, I think, than the AP test does. Doesn't mean there aren't some weird, clever questions on the AP test, but for the most part, we overcover limits. So when you take the AP test, it's not a big deal. So here are some random questions that would be very AP-like. So number one, it gives you a function, a piecewise function, and it says which of the following is true. Number one, the limit of that function does not exist as you approach 3. So what has to happen for a limit to exist? And what, she said the left and the right would be the same. What do I look at to check left and right on this piecewise function? The first one, right? Because not equal means greater than or less than when it comes to a piecewise function. So I would plug a 3 in there to figure out what happens left and right. When I do that, I get 0 over 0. What does that imply? There's a hole there. Oh, this is a beat. All right, so what do we do with a hole at this point in our limits career? We if it's not a trig function, we factor and cancel. When we do that, I get an x minus 3, x plus 3. The x minus 3 is canceled, leaving me an x plus 3. And then I plug it back in and redo the limit. So that would give me a value of 6, which implies that there is a limit, right? And the value would be 6. So the limit does exist. All right, what about f is continuous at 3? What has to happen for something to be continuous at a value? The limit has to exist, which we've already checked. The value has to exist, and it does give us a value at 3, and they have to be equal. And you just checked the limit and got 6. The value at 3 is 6. So the limit exists, the value exists, and they were equal, right? And I'm paraphrasing that. I should say the limit of f of x as x approaches 3 exists. The value of f of 3 exists, and they are both equal. I should say that really clearly in words or expressions or whatever. So that also is true. Then it says the line x equals 3 is a vertical asymptote. Is that true? No. Why not? Because there's a hole at 3. Looks initially like a VA, but we already saw that there was a hole there. So 3 is not true. So 1 and 2 are true. You have to go with D. You with me? Great. I mean, very AP sounding, that question. Number 2, the limit of sine of x over x as x approaches infinity is what? Now, a lot of people look at that and they're so used to seeing sine x over x that they grab the 1 and the 1, they go 1 over 1 is 1, and they grab b and they miss it. Because I'm not going to 0, am I? So if I'm going to infinity, what is happening here? Now think about that fraction. What is the sine curve doing? It's oscillating between negative 1 and 1, right? So it's hitting every value between negative 1 and 1 an infinite number of times. And we said that a limit at, if you were oscillating, would be dne because it is not approaching a single y value. But the answer to this is not dne. Even though that looks very good and is a true statement, that's not our limit. Because what's happening to the line y equals x, or the denominator? What is it doing? The line y equals, I have y equals sine x, y equals x, essentially.
The bottom is increasing faster.
The bottom, as I go to infinity, is getting huge, isn't it? It's going to infinity. So essentially what's happening is, even though the top alone would be a dne, I'm basically taking a really small number, something between negative 1 and 1, and putting over a huge number. And what happens to a fraction that size? It shrinks to 0. Are y'all seeing that? So if it had just been sine x, I would say dne. But because it's sine x over x, and I'm going to infinity, this particular fraction is getting smaller and smaller and smaller. So I got to go with 0 on this. Are y'all with me? All right, what about this over here? This is probably something that we haven't talked directly about. But if you're clever, what happens if I plug a 25 in it? I get 0 over 0, right? Because I'd get 5 minus 5 on the top and 25 minus 20. So what do we normally do when we get 0 over 0? Can I factor that?
Yes.
Can I? Now, normally we think, oh, it'd have to be h squared minus 25. Lily sees it.
The square root of h minus 5 times the square root of h plus 5.
Right? You get really creative there. That could be factored as root h minus 5, root h plus 5. Think about it, right? And if that happened, I'd be able to cancel that and that, leaving me 1 over this. And then when I plug that back in, what would happen? I get 1/10. Now, if you don't see that there, it's okay. There are a couple of options that you could employ. So like, here's one other thing you could do. You could multiply the top and the bottom by the conjugate of the numerator. You're basically rationalizing the numerator. So what if I multiplied the top by a root h plus 5 and a root h plus 5 on the bottom as well? What do I end up getting on the top? I get h minus 25 on the top over the h minus 25 root h plus 5 that's on the bottom. Those would cancel, and I'm right back to where I was a second ago, plugging in a 25 and getting a 1/10. And the third way is L'Hopital's rule, which we don't know yet, but would bail you out once you learn derivatives. You'd be able to apply L'Hopital's rule. All right, what about this? Suppose the limit of the function is 5 as x approaches 2. The limit of a different function is 6 as x approaches 2. And there is, what do y'all see there? What does that say to you? So there's your f, there's your g. You know the limiting values of those at 2. This says what? There is another function that is both greater than or equal to that one, less than or equal to that one, which tells me in between those two for what? All values of x. So it is either equal to or in between. Now, it says which of these are true. So can you give me a visual representation of what this is saying right here?
Two functions and then the one in between that either touches it or stays.
So what do we know about f and g right here? As f approaches 2, my limit is, so what happens at the point 2, 5? Is there a point?
There's no.
There could be a point, but I don't know that for certain. There's a limit. So there could be a hole. There could be a point, but I know there's at least a what? Come on, guys. If there's a limit that's 5 as I approach 2, then at 5, what do I know right here?
There's something.
I'm approaching at least a hole. Because if I know there's a limit, it's got to be approaching 5. I might be filled in, but I don't know that for certain yet. So right here, this f function, let's just say it looks something like this. I don't know, but I know that it is approaching a 5, this f function. At 2. Are y'all with me on that? Might be colored in, but I don't know that, so I can't assume that. Now, what happens to g as it approaches 2? So up here at 6, it's approaching what? At least maybe that. So there's your F, there's your G. Are y'all seeing that? But I know there's at least a hole there because the limit does exist. And then what does this say? It's somewhere in between them for every x. Now that to me suggests that there must be a point there. Because if its values are in between there or equal, so it could be equal, but if it's in between there or equal for every single x value, for all the x's, that suggests to me that it would also have to be true at g of 2. Are you with me? And if it's true at g of 2, that suggests that g, if it has a limit, that it either has a value there, actually, it either has a value there, or it's possible that g might be one of those where it hops down to a point. Are y'all with me? So I guess it's possible, and I know that let me erase this. Okay, it's possible that something like this happens. Are you seeing how I'm going through different options of what h is? It's possible that like that the actual h function, isn't it still less than or equal to g if g went straight through there? Yes? Mm-hmm. So you got to be kind of clever and creative when you're thinking about this, but it could be lots of different options. But just for the sake of thinking right this second. Oh, there we go. I'm just going to do this. I'm just going to think of h right now as somewhere in the middle. I'm not even going to draw it right there. And let's just walk through these. First thing, does f of 2 have to be 5? No, we already saw right there that this could be f right here. Right? That might be f where it has a little point right there and then continues. So does that have to be true? I'm going to say no. Second thing, the value of g is smaller than 6 for every, do y'all hear this? The value of g, that's the y value of g, has to be less than or equal to 6 for every x value bigger than 2. So here's g. Does it have to be, now I know I drew my picture this way, but does the value of g have to be smaller than 6? That doesn't even make sense, right? I mean, here, right there, I have g bigger than 6 for all these values. G could have actually taken a turn like that as well, though, right? It might have been true, but does it have to be true? Are y'all seeing that? Again, if I write g of x, that means the y values of g for that x, for x is bigger than 2, have to be smaller than 6. Well, you can see right there the y values of g were bigger than 6. So I would say that doesn't have to be true. Right here, does the limit of h have to be between 5 and 6 as x approaches 2? Tell me why you think no, Hill. What you're saying it. There's a lot of functions. I don't know what you're talking about.
You drew the f dot below. This has to be between f and g.
H. Does the limit of H have to be between 5 and 6?
Yes. Yes.
Now, this is why a lot of the people miss this, including me. I originally said that's true and went with C. And then I went back and went, did anybody ever say the limit of H had to exist? What if H did this? What if H, say, went to there and then hopped up a little bit and finished? Is everything else true? Are the values of H between F and G? Well, you could argue there's the value of G, there's the value of F, there's the value of H. That's true. And that's true everywhere else, right? All these values are. So is it possible, I'll kind of blow it up. Is it possible that, say, G looks like this, F looks like this, but at 2, H looks like this?
Oh.
And if that's true, the limit doesn't even exist, does it?
No.
So in that case, this wouldn't even be true. Now, if H looked like that, then that would be true. But I don't know what H looks like, so I can't make any assumptions. I know some of you right now are like, how am I going to know that? Sometimes you don't. That's why you only need to get 66% of your, actually it's less than that, 66% of your AP test correct to get a 5. All right? So it's not like you're going to get everything. You're not. If you even get close to everything, it's amazing.
The AP scale, like in your test and AP scale.
Depends on who teaches it to you, but
Like an AP physics.
they consider it, or they let you do corrections. That's what I do. And I don't put I don't make the entire test AP like questions, although they do that in physics and then let you do corrections to get a ton of your points back.
Yeah.
So right here, be careful on stuff like this and don't jump to conclusions, because it's possible that would be true. And even though H's values, every H value is between or equal to F and G, isn't it? Every one. But the limit doesn't even exist. And if the limit doesn't exist, this is not true, is it? That doesn't even make sense. So I can't say that that's true either. So it ends up being none of these. And that's a tricky question. If you look at something like that and you look at when they release an exam, they show what percent of the students got that question right. And it used to be multiple choice A through E. Now it's A through D. But an old question like this, sometimes you'll see 17%. And you're like, that defeats the laws of probability, right? A blind monkey would get 20%, just random pecking at letters. But sometimes it's so tricky, people go, oh yeah, it's that. And everybody gravitates towards C because they know a lot, but they fail to think about certain conditions. So sometimes you'll see a really tricky question like that. Yes?
That's a question that goes, that could be on the test.
I don't know. Sometimes I throw weird stuff on there.
You throw
Sometimes when I do, though, it might be a bonus question or something like that. So no, something like that, probably not. But if it was, it's probably a bonus. How about this? F is continuous on 2 to 6. What does that mean if it's continuous? From 2 to 6.
the limit.
That
value
means-
are the same.
The limit would exist at every single value. Now, I could leave you tons of holes, though, right? But also what? The value would exist. Now, that means you might not have holes. You could have jumps. But then it also means what?
You have to be the-
They're the same. So essentially, there are no holes, no breaks, no jumps, no asymptotes at all on this graph. But there still could be funny corners and cusps. We haven't even gotten into that, have we?
No.
No, there could be funny behaviors on it, zigzags, things like that. But bottom line, no holes, no jumps, no VAs if it's continuous. Now this says F of 2 is 20 and F of 6 is 10. So if F of 2 is 20, what is that giving me right here? A point. So they're telling me basically at 2, I'm up here at 20. Then they're telling me at 6, I'm what? I'm up at 10. So I've got a couple of points basically at 2 and 6, but it says it's continuous. So you know that between here and here, what happens? What doesn't happen? No holes, no cusps. No holes, no VAs, no jumps. right? So the intermediate value theorem, you don't know what that is, but I'm throwing it out here. It's a little learning lesson for you. The intermediate value theorem says, if you have a continuous function, which you do, that to go from here to here, what am I going to have to hit? I'm starting at a y value of 20. I'm ending at a y value of 10. What am I going to have to hit on my journey from there to there?
All the y values in between.
Every y value between 20 and 10. I have to. I have no choice. Now, I might hit them a zillion times, right? That's not a zillion, but like I might hit them a ton. I might only hit them once, right? I might hit them, a couple times, but I have to hit every y value. Think about it. I have to hit every single y value at least once from there to there. It'd be kind of like, what if I'm at time 2 going 100 miles an hour? And then at time 6, I'm going 50 miles an hour. Can I somehow skip 75 miles an hour? I mean, if I slam on the brakes, aren't I going to decrease? I mean, I don't go and just jump, right? I mean, even if I slammed into a steel wall, which might immediately stop my front end, what's happening to the rest of that car? So even I am slowly decelerating from 100 to 0, but I'm gonna, right? It's gonna be like, I'm gonna feel my body slowly crunching against itself,
And
and then I die. Yes, but right, even that.
just like in this problem.
But I do. The intermediate value theorem says that if I am continuous, that I am going to hit every single y value. So and then it says, which of the following is true? I'm going to go back to my picture. So this says, what does that say right there? This is me trying to teach you how to read problems. So I know this point exists, and then I know that point exists. What does that say? It says y equals 30 does not have a solution on that interval. Y equals 30 would be where? So there's the line y equals 30. It says it does not have a solution. Not have a solution means it doesn't what? It doesn't have a solution on f. But you know that f is going to be from there to there. Now, does it have to go straight down? It could come down like this. Could it go up and cross? So do you know with certainty that that's true? It could be true. It might not have a solution. If this y function that connects this and this doesn't go high, then it would be true. But does it have to be true? No, so you get rid of it. And usually they say which of the following must be true. But that's implied in it. All right, what about this? F of x equals 16 has a solution. Now that has to be true because right there, f of x or y equals 16, that the intermediate value theorem says to go from here to here, if I'm continuous, I'm going to have to at some point cross that. So I know that has to be true. Now, if I don't say continuous, if I don't say that, then that's not true. So if I didn't say f is continuous, isn't it possible that my function looks like this? Right? There's a jump, and that would never have a solution. But if it's continuous, which is one of the conditions of the IVT, the intermediate value theorem, then that would be true. All right, so this one is true, and this says f of x is 0 has a solution. Here's my f of x is 0. Does that have a solution? Not necessarily. Might, but not necessarily. So I'd have to toss that and go with 2 only. All right, what about this? Number 6, the limit of that as x approaches 4 from the left. What do you do when I go from the left? I still plug 4 in and see what happens, right? I don't know. It might be fine. It might be just a random number, right? But when I plug a 4 in here, I get 10 in the numerator, and I get 16 minus 24 plus 8, which is 0 in the denominator. So what does that mean right here if I got 10 in the numerator and 0 in the denominator? So I know there's a VA. I know that with certainty, right? So if I know there's a VA there, what do I now do to check 4 from the left? I don't factor. I don't need to do that because there's not a hole there. I've got to think what would happen if I plugged like a 3.9 in. Now, I will say this. On this one, I really don't want to plug 3.9 in. I really don't. Okay? So sometimes factoring might help you. Like, for instance, right here. Because really, what am I concerned about here? What do I really want to know?
A little bit less.
Right, but what am I looking to see? Infinity or negative infinity? So to me, it's all about whether it's positive or negative, right? So isn't it a little easier to say if I did factor it, if I plugged in, say, a 3.9 right here and a 3.9 right here, what do I end up getting? A positive times a negative, which is a negative. See how sometimes it might be easier if I did factor to figure out that on that side, it would be negative on the bottom. And what's the top going to be when you plug a 3.9 in? You don't even have to bother with it. Even if it was ugly, it's still going to be really close to a positive 10, right? So I get a plus over a minus. What does that tell you? It must be going down. Now, if you didn't even think to factor, then just type in 3.9, not type it in. Multiply out 3.9 squared, subtract 6 times 3.9, and add an 8 to it. It's going to be really small, but at least you'll be able to determine whether it's positive or negative. So I'm going down on that side, must be negative 50. All right, what about number 7? You've actually done these before. I plug a negative infinity in there. Well, I can't even plug a negative infinity here. So what do I normally do when I have infinity problems? And a fraction. So thinking about growth rates, right? Which growing faster? But what's a square root of an x squared? Absolute value of x. So if I think about this, this is essentially me thinking about 3x, blah, 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 over absolute value of x, blah, blah, blah. This is like that. Now, I use coefficients when there's no absolute value, but there's still an absolute value. So how do I think about absolute value? If I'm going to the right on an absolute value, like to positive infinity, then I use the positive version of that, right? But if I'm going to the left, which I am going to the left, right? If I'm going to the left, I would have to use the negative version. So essentially, because I'm going left, this becomes Are you seeing that? And now I know that in this situation, when my powers are 1, I can just take 3 over negative 1 and call it a day. Are y'all seeing that? Yeah.
Wait, could you not just like plug in the negative, like make the top x negative and assume that the bottom's gonna be positive?
Yes.
Okay.
As long as you, in your head, recognize that that's the same power as this.
Yeah.
As long as you're right here thinking, okay, these are the same powers. If I plugged a massive negative number there, I know it's going to still end up being positive. If I plug a massive negative number there, I know it's going to end up being negative. As long you could get the sign that way, but then which is essentially the same thing, but make sure you're remembering that this doesn't end up being negative infinity, right? The powers are the same, so I'm thinking coefficients. But don't put a positive 3 over a positive 1. Make sure that you understand if you're thinking that way. I'm trying to relate this to a way that you already know how to think through, which is when your powers are the same, use the coefficients. But you've got to get there in 2 steps. One, get rid of that square root of the squared, and the other, get rid of that absolute value. A college textbook would teach you like this. They would say, okay, you take your 3x and your positive 2, you take your x squared and your 4, and you divide everything by the highest power in the denominator. Well, the highest power in the denominator is x squared under the radical. So if I divide this by an x squared under the radical, I get this. But what is an x squared under the radical here? It's an absolute value of x. And what's an absolute value of x? Well, it depends on what? It depends on whether I'm going right or left. And since I'm going left, what does that become? Negative x. So a professor would basically teach you like this and then say, all right, now do your limit. So what happens? These x's cancel, leaving me 3 over -1. These x's cancel, leaving me a +1. And if I plug a massive number there and there, what do these fractions become? Zeros. And I end up with -3 over a 1, which is -3. So you can think any way you want, but at some point you're going to have to recognize the square root of an x squared is an absolute value. And what does this tell you about absolute value? I kind of like the original way I did it, but this is more conventional thinking if you were like in an AP calculus class. All right, what about this? If f is continuous for every x value, what's the maximum number of horizontal asymptotes that the graph of f can have? If it's continuous, the maximum number of horizontal asymptotes. Is there not no maximum number?
All.
0. Why is it not 0?
If it's continuous, like,
If there is no maximum.
so you're saying there cannot be a horizontal asymptote ever.
No, it's right? It can't break. Oh, wait, horizontal, never mind. I'm thinking like the other thing.
Vertical. Yeah, huge difference.
The other.
Yeah.
No, the rule thing, the intermediate value.
So if I have a horizontal, how many can I have?
3.
Be creative, guys.
Obviously three.
If f is continuous, it could be any function on the planet.
There can't be a maximum value.
Can
Yeah, there's no max. It could be like a sine curve.
No, could it be 2?
It's
Only
continuous.
The sine curve doesn't even have a horizontal asymptote.
There can only be 2.
Exactly. Wait.
It's either 1 or 2.
Yeah, it can be from the point upwards and like from the
So
bottom,
that's what-
if it's continuous.
So
So 2.
2. Yeah, I mean, think about it. Can't I
It's
have?
gonna be on our pads.
Oh, maybe. I mean, can't I have a graph that does this?
Sure,
And there's a horizontal and there's a horizontal?
absolutely.
But I can't have 3. If I had 3, what would that mean?
Actually, that makes sense.
If I had a third one, how can I approach this one and that one? I mean, what would be wrong about that? It's not a function. If it's a function, I can only, guys, remember, what is a horizontal is doing? A horizontal asymptote tells you what a graph does as you go forever to the right. A horizontal asymptote tells you also what a graph does, it goes forever to the left. Now, the graphs that we've dealt with, like rational functions, they only have one horizontal, if any, right? They don't have 2. But piecewise functions or weird functions you haven't run into yet, they can have all kinds of things. But I can't have 3 because there's only one right and one left. And if I approach 2 different horizontals forever, it wouldn't be a function, right? Are y'all seeing that? So the most that could happen is 2. I mean, very likely, but that's not it, and that's not it. I might have one. This is what normally happens with the graphs that we have done up to this point. We're either going to have 1 or none, like parabolas don't have them, and slanted lines don't have them. But I could possibly have 2, but this is not an option, right? Okay. And again, Pete, remember, a function, if it's continuous, it could still be weird, right? I could have, I could have a something looking like this, and then I could jump up to another line and have something else looking like this. And I could have different horizontals. I mean, it could be, it didn't say that it had to be some, non-piecewise function. It could be anything. All right, if f is continuous, the maximum number of vertical asymptotes.
That is. Oh, wait.
If f is continuous. Yeah, I can't have if it's continuous, there can't be holes, jumps, verticals, so I can't even have a vertical. Now, if I didn't say continuous, if I said for a random f, the maximum number could be what? There's no max. It could be an infinity, right? Tangent curve, secant curve, anything other than sine and cosine that's a trig function. You're going to have an infinite number of verticals, right? Lots of places where it's undefined. All right, what about this thing? This is something that you would not have, so I'm not going to talk about it. Or am I? Nah. It showed up once on a test. It was one of those that like 13% of the people got it right. I don't know why I keep putting it on it. The domain of F is this. So what does that tell you?
It starts at 1 and goes up
It
to
starts at an X value of 1. I don't know what the Y value is, but there definitely is a Y value of 1 and it goes forever to the right. Y'all see that that's what that says. And then what does F of 1 equals 0 tell you? So you have a point there. So not only does the domain start at 1, but the actual point is at 1, 0. So I know that at 1, 0, there is a point and it is heading off to the right. It says the line y equals 3 is a horizontal asymptote. So y equals 3 is the horizontal asymptote of this graph, which means as the graph goes forever to the right, that's what it's approaching. But it only starts at 1, so nothing happens before that. Which of the following must be true? The graph of F never meets the line y equals 3.
No, because you got John's over and then do it right. Yeah.
All right, so if I say never, or I say it must be true, you have to think of every scenario, not just, oh yeah, it approaches there and never hits it. First of all, you can hit horizontals. I mean, there are sine curves that cross horizontals an infinite number of times. Not regular sine curves, but like sine of 1 over x. It might cross a whole bunch of times. Okay, so you can cross horizontals. There's nothing wrong with crossing an asymptote. You just can't cross a vertical asymptote because it's undefined. Other ones aren't undefined. So that could totally have happened. So never meets the graph? No, that's not true. This says the limit of the function as I go to infinity is 3. That's the very definition of a horizontal. A horizontal asymptote is asking you, what y value am I approaching as I move forever to the right? That is literally what this is saying. I'm approaching a y value of 3 as I move forever to the right. That is certainly true. F is an increasing function. We haven't talked a ton about increasing and decreasing, but what do I mean when I say increasing? As I move where? As I move to the right, the y values are getting bigger, which means it's going up. Right? So when I say increasing function, I mean y values are increasing as I move to the right. Now, is that guaranteed? It might be true, but that first picture I drew showed that it doesn't have to be true. Right? So if you can think of a situation where, wait a minute, if it did this, it would be increasing and then decreasing, well, then that wouldn't be true at all, and you'd have to go with B. All right, what about number 12? What would you do in a problem like this?
Plug it in.
Plug in a 2, see what happens. I plug in a 2, I get 0 on the top, and I get 0 on the bottom. So what do? I do what? I do have to factor, but is the absolute value going to bother you here? So can I get rid of the absolute value? If I'm going from the left side, right? I know this is not a V absolute value graph, but we know our definition of absolute value. Sometimes it's positive, sometimes it's negative, right? It's the positive version of that as I head that way or come in from that way. But it's the negative version of that if I head that way or come in from that way, right? And I'm clearly coming in from the left side. So what that means is all I have to do to get rid of my absolute value, right? All I got to do, I'm going to go ahead and factor this while I'm here, is negate this thing. And then how does that factor? And I'll give you a hint. You know there's a hole there, right? So you know there's going to have to be either an x or an x minus 2. So x minus 2, x plus 1, but a negative. So that negative showed up in there, and now I can cancel out my hole, but there's still a negative, and I can go back and plug 2 in again. And this time when I plug in a 2, I get negative 2/3. But 2/3 is the most commonly chosen mistake. That's not right, right? It's negative 2/3. Because people forget about, they just think, oh, factor it and cancel. And if I were to just do this, guys, if I were to do this and then just cancel, look what happens when I plug the 2 back in. I get 2/3, don't I? I have got to address the absolute value. The absolute value, so that's wrong, but it looks very right. The absolute value has to be addressed. And if I'm coming in from the left, use your definitive absolute value, use that definition to get that in there so you don't make this mistake. Yep.
What is this test on? Is it trig limits
Limits,
or is it limits period?
everything. At this point, everything.
So, okay. That makes more sense. I thought it was just on trig limits. Why are we? But that makes
Yeah, everything. But it will have trig limits for certain. All right, what about this? 13.
more sense.
F is continuous on the interval from 1 to 8. What am I essentially giving you in this chart? 4 points. One which starts at 1 and one that ends in 8. So I actually know the points where it begins and ends, and I know a couple points in the middle. So when I'm given information like this, like to see it better than a chart. So I always sketch something. It helps give me a visual. So I know at 1, I'm down there at -2. I know at 8, I'm up here at +6. And I also know that somewhere in the middle at 3 and at 5, at 3, I'm up here at 4. And at 5, I'm up here at 10. So there's a point. There's a point. There's a point. There's a point. And there's a point. Now, answer this question, which has nothing to do with this. What does your brain naturally think?
Cosine. Sine.
Think more simple.
Parabola.
You're trying, but what is your brain trying to do? Connect those. And what does your brain naturally tend to do? Connect them the smoothest way possible. That is not a guarantee, though, is it? You have to get away from that. On problems like this, your brain naturally goes, oh, I bet this is some kind of maybe a cosine, maybe a parabola, maybe some. Get away from that thinking. All you know is that it's continuous. This thing could start and go down 1,000,000 miles before it comes up and hits 3-4. And then it could go up 1,000,000 miles before it comes down and hits 5-10. You don't know what's happening. This thing could zigzag an infinite number of times before it finally hits this point. It could just be some crazy tiny zigzag cosine function that just happens to hit these 4. You don't know. But what you do know is that there are no what? No VAs, no holes, no jumps. Because that's what continuous is telling you. Okay? So what must be true? What does number 1 say?
There's a solution.
Y equals -3 has a solution. Well, here's y equals -3. It's right there. Does that have a solution? Could, but does it? If I can't say for certain some way, I don't know, can't count it. Could. Certainly this graph could keep going down. Might not, though, might head up. Who knows? Second one, y equals 0 has a solution. Why?
The theorem.
The IVT, right? Intermediate value theorem. Yeah, I'm not going to make you quote that. Yeah, the intermediate value theorem says continuous functions are guaranteed to go through every y value between the minimum and the maximum y value. You're guaranteed to do that. Okay, and so you see if that's my min and that's my max, I'm going to hit every y value on that journey between those x's. All right, so yes, definitely. Y equals 9 has a solution. Yes, again, intermediate value theorem. So I know that those two are true, but make sure that you're reading this as y equals 0, y equals 9. And that says the y value at every x is 0 on that interval. And that's basically y equals a line. So 2 and 3, so it must be D. All right, this is another one of those ugly ones that just doesn't matter. And those are your answers.
Oh,
right.
Actually,
How we feeling?
I feel like I know the best.
Hey, go back. I know it's been a while. Hopefully you got to decompress and rest a little bit over your break. But maybe go home. And again, if you study tonight, like your test is tomorrow, go back and look over all that stuff. Then you can use tomorrow to kind of troubleshoot. When you see something weird like, oh, yeah. You wait till the end, or don't study at all.
No, I'm not. Thank you.
And you will join the few, the proud,
The Navy and the
curb,
30.
the curb stomped. Don't let that happen to you.
You the proud of the 30.
I've had them.
Understands?
Yeah. Not a lot of them, but I've had a lot of 60s. It's this week in soccer with my. Or is it? You got Mountain Brook and Briar with us? Where are they? Is it Walden? Let it get out there. Anyway, it's softball with our.
We play Bonneville tomorrow, if it doesn't rain, and then we play Mount Vernon.
They good? Great chocolates, always. They're not? When I hear Country Town, I think
Oh,
those big, extra sturdy ladies that can just like truck a softball.
we're just really small, like size wise,
Yeah.
everybody's tiny. And we're losing like 8 seniors next year.
Oh, wow.
And they're basically like, they're all of our starters. We have like 8 seniors.
You're losing them after this year.
Yeah. So next year we'll just have 3 seniors and then. Yeah,
Rebuilding. We had a girl named Keegan Ballinger that when I taught regular pre-cal, she was in my class. But she played shortstop. She was probably your size, but maybe a little shorter. But she was just she's real cute and then just mean.
Oh,
Like
really?
real in class. Like once we played, Helmers and I used to coach, what's this football, Powder Puff? We were undefeated. Only scored on once. But anyway, we played Powder Puff and she was our quarterback. And I'm not kidding you. She ran a play once and it blew up. So she just went forward, ran over a girl, stepped on her chest with cleats and kept running. Like, filthy. Yeah, she went nowhere to go. Truck this girl step. Like, oh my God. I'm just she was just filthy. She played shortstop for the soccer. Anyway. Bruh. Hey guys, there's some good reviews to do with this tonight.
Right?
See ya. Have a good one.